Okay, so this is the first question of the test based on AQA FP2 question. It was the first question on that paper also, so it should hopefully be reasonably straightforward. Minus 9i, it's got an if you were to draw our Arzan diagram, would be down that way, so it's got an argument of minus pi by 2. And it tells us the range. We need our argument, which is fairly standard anyway. And it's got a modulus of 9. It's got a modulus of 9. So the modulus is 9. The modulus of z equals to 9. So 9 minus 9i is equal to, and it wants it in r equals to e to the I theta form. So that's 9 e to the minus pi by 2 I. That's the first part done. Okay. The second part, we're using de Moivre's theorem. So we've got z to the 4 equal to minus 9i. So z to the 4 is equal to 9e to the pi by 2 I. But let's that. Remember, this was the principal argument. So if I add any multiples of 2 pi onto that, I still get the same thing when I evaluate it, because it's all to do with the 2 pi period of the sine and cos graph both happen in period 2 pi. So we have z to the 4 is equal to 9e to the minus pi by 2, let's bracket this, plus 2 pi n I. Okay, now we then use de Moivre's theorem. So we have z is equal to 9 to the power of a quarter. Now let's just take each of these, divide by 4. We're basically dividing the whole lot of this by 4. So, and that's going to give us minus pi by 8 plus pi n over 2. Oh, we can simplify that. Simplify that too. 9 to the power quarter is equal to the square root of 3. E to the minus e to the pi bracket. Let's do pi over 8 bracket minus 1 plus 4n I. Right, now we need to be careful with the argument again, because it's talking about the range being the principal argument being between minus pi and pi. We need 4 consecutive values of n, but we need to express the argument in the form they want it. Obviously we would have n equals minus 1, n equals 0, should give n equals 1 and n equals 2, should give us all of the solutions, but we'll see. 2 might go over, which, no it won't, it should work. So n equals minus 1, that gives us z is equal to the square root of 3 e to the, put minus 1 in there, minus 5 pi over 8 I. N is 0. That gives us z is equal to the square root of 3 e to the minus pi over 8 I. And n equals 1. Z is equal to the square root of 3. That's going to be 3 pi over 8. Difficult to see that 8 there. I. And the fourth one, we could number these as well, Z1, Z2, Z3 and Z4. These are the 4 roots of 4 fruits of minus 9i, square root of 3, e to the, now put in 2 in there, 7 pi over 8. And now they do lie within our given range. So these 4 values were chosen so that our argument was between minus pi and pi. So it's done. If we were to repeat, this with more values, we would just get overwritten values. So for example, if I was to put in n is 3 in there, that would give me the same actual complex number as n is minus 1. So it would just go around like that. Okay, but it would not be accepted here because they want us the argument expressed between minus pi and pi. Okay, so each one of these, it's not required here, but if some people would prefer this form is minus 5 pi over 8 plus I sine minus 5 pi over 8, but they didn't want that form. They wanted this, so that's what's done. Question's done. Okay, there we go. All over.